Hello students, welcome to the series of lectures on digital speech processing. In this video, I am going to explain about classroom discussion topic on pitch period estimation using autocorrelation function. So in the previous video, we have already seen, we have talked about what is an autocorrelation function and what is a mathematical expression of the autocorrelation function and what is the short time autocorrelation function. That means by applying windowing techniques to the autocorrelation function, and we have taken the complete speech signal and we have divided into the frames, and we have applied the windowing techniques, and we have calculated the autocorrelation and we have plotted them on a graph. Okay, so that way we have already seen the basic idea about the autocorrelation function and the objective that we have seen. Now in this video, let's talk about the estimation of pitch period using autocorrelation function, which is very popular. Okay, so the estimation of the pitch period is very popular with the help of the autocorrelation function. Okay, so let's get started with this. Alright, so on completion of this lecture, you will be able to estimate the pitch period using autocorrelation function. So now, before we understand how we need to estimate the pitch period, now let us first understand what is a pitch. Okay, the speech signal can be classified into the voice, unvoiced, and then silence region that we already know. The voice region looks like a near periodic, that is why we are calling them as a quasi-periodic. Okay, so in a short term, we may treat the voice speech segments to be periodic for all the practical analysis and the processing. And the periodicity associated with such segments is defined as a pitch period. That is in the time domain. But when it comes to the frequency domain, we are calling that as a pitch frequency or fundamental frequency. So let me take the pen. So we are calling pitch frequency or the fundamental frequency F0, that is in the frequency domain. Okay, but we are calling the pitch period, that is T0, in the time domain representations. So pitch, it is an important attribute of the voiced speech. Please understand, the pitch can be calculated for the voiced speech, and we are not going to be expecting any estimation on the pitch for the unvoiced speech signal. Okay, so it is measured, and in some other words we can also see the definition like it is measured as a time difference between the two major peaks in the voice and speech signals. Actually, that shows a very important to take the autocorrelation function, and from that autocorrelation function we are going to be estimating the pitch period, because I clearly mentioned the definition here in the brackets. It is measured as the time difference between the two major peaks. As we already know what is the objective of the autocorrelation function also. It is also the time difference between the two signals. Okay, one is the same signal and another one is the delayed version of the same signal. Okay, so that is a motivation actually towards the calculation of the estimation of the pitch using this autocorrelation function. So the estimation of the pitch is one of the most important issue in speech processing. So pitch period estimation using the autocorrelation function is a common method for determining the fundamental frequency of a sound or the speech signal. So the basic idea behind this method is that the pitch period of a signal is a point at which the signal's waveform is most similar to itself. The same way how we have already talked about the autocorrelation function. And the autocorrelation function, which is used to measure this similarity, that's all. The degree of the similarity we are going to be calculating, right, in the autocorrelation function. So let us see the general steps for pitch period estimation using this function in the next slide. So the first step, we obtain the input audio signal, and which can be sound or the speech signal. And step 2, we are dividing the input signal into overlapping frames. So each frame should have a length of at least 2 pitch periods. And next step is that we are going to be finding the maximum value of the autocorrelation function in each frame and its corresponding lag. And the last step is that select the frame with the highest maximum value and use its corresponding lag as the estimated pitch period. So this is the process actually we are going to be doing to estimate the pitch period using the autocorrelation function. Okay, so we also know which is equal to the inverse of the fundamental frequency of the vibration of the vocal cords and it only makes sense to speak about the pitch period of the voiced frame of the speech. And there are a number of techniques which are used to determine the pitch period. One is the time domain and then frequency domain. But we are more interested in the time domain process. Okay, so how we are going to be using the time domain? We are going to be the speech signal on a time scale, the 40 milliseconds of the speech or 20 milliseconds of the speech or whatever that you consider. And we are going to be taking the frames and we are calculating the autocorrelation function and we are estimating the pitch period from that. That's a way. And in the frequency domain, we are taking the segmentation of the frame of the speech and we are applying the Fourier transform because we need to convert into the frequency domain. Okay, either you can use the Fourier transform or any kind of the transformation technique that you can apply to convert from the time domain into the frequency domain, and we are going to be seeing the spectrograms. And from there, we are going to be calculating the pitch period. These are the two important ways we will be having for estimating the pitch period. But we are most interested towards the time domain process. So this is the voice segment of the speech. Okay, so as an example, I have told, so any kind of the speech signal when you consider, and this is the speech signal actually you'll be having. So these are the peaks. Okay, this is a peak 1, peak 2, peak 3, and like that. But what is the pitch period? So this is nothing but your pitch period P. Let me call this as the P. Yes or no? We are interested towards the calculation of this distance, the distance between this peak to this peak. And here also the same, the distance between this peak to this peak. So what we are doing is that we are going to be taking the short time autocorrelation function and we are taking this segmentation and analyzing the what is the peak, and we are taking the two peaks as the difference is nothing but your pitch period. So that way we are going to be estimating. This is a pretty simple approach to estimate the pitch period with the help of this autocorrelation function. Okay, so total how much of time duration we have taken as a voice signal as a 40 millisecond duration. Okay, so from 0 to 40 millisecond duration, this is the segment option. These many segmentation we are going to be applying by applying the windowing techniques to the speech signal, and we are going to be estimating the distance between the two peaks and nothing but the pitch period. So this is an autocorrelation function. Okay, so the previous slide, that is a voice segmentation of the speech we have considered, and I clearly mentioned to you the pitch period we are going to be estimating for only voice speech. That is a makes sense to us. Okay, for unvoiced speech there is no calculation of the pitch because pitch is 0 at all. Okay, now so this is a energy signal I can call, because we have taken the delay. There's a k value, for instance, this is k, and this is autocorrelation function, this is pi of k. Okay, let me write like this. This is pi of k, autocorrelation function. And we know the mathematical expression. So for if there is no delay, that is k equal to 0, and you'll be getting the energy of the signal. Okay, you remember the mathematical expression that the x of n into x of n plus k or n minus k, whatever. So if k equal to 0, then x of n into x of n, that becomes x square of n. That is an energy. Okay, so similarly here the another peak will be having, and here also one more peak will be having. And for instance, the duration, here this is a 7 millisecond. Okay, this I am calling as the first peak, k equal to p. Okay, and similarly this is k equal to 2p, the twice of the pitch period. We are taking the k value as a twice of the previous pitch period, and this can be available at 14, for instance. This is a 14 millisecond duration. So what you need to understand, so this is the interest. We are going to be interested towards the calculation of the difference between the two peaks is nothing but the pitch period. Here also the same difference between the two peaks, we are going to be calculating the pitch period. So this is very simple approach for us to estimate the pitch period with the help of this plot also. Okay, so almost it doubles the 7 at k equal to p, that means at 7 millisecond we'll be having a one peak, and at a k equal to 2p, because p equal to 7, 2 times of 7, that is a 14 millisecond, and there is another peak. So between two peaks we are going to be estimating the pitch period. That's all. It's pretty simple for us to estimate the pitch period with the help of this autocorrelation function. Thank you, student. Thank you for watching this video.